Okay, so this is chapter 3, section 3, position time graphs with constant acceleration. Okay, so we've talked about acceleration and what that is and what motion with constant acceleration is. And so now we're going to look at our position versus time graphs and what those look like in a situation where you have constant acceleration. Okay, so let's go ahead and do this. All right. So the shape of the graph will contain a lot of information, like most of them do. All these position versus time graphs that we do contain a lot of information that can tell us about the velocity, about the speed, and about the acceleration of that object. So here is our data table, and then here is our actual graph. And you can see the graph just gives us more of a visual for what's going on in the data table. Okay. All right. All right, so constant acceleration. When you have an object in constant acceleration, it's always going to produce a parabolic position versus time graph. It's not going to be a straight line anymore. Because remember, in the straight line position versus time graphs, our slope was our velocity. Okay, but our velocity is not going to be constant anymore. Our velocity is going to be changing. Okay, that's how you get acceleration, is you have a change in the velocity. So since that's the case, we will no longer have a straight line. We will have some form of a parabola. And this graph just shows you all three of those situations. So this is our straight line. This would be where we have zero acceleration. So that would mean that velocity is constant. I'm not doing this on my touch screen, so it looks like a kindergartner. And these other two, these parabolas, these curved lines, are where we have velocity changing, and therefore we have acceleration. So you can see if the velocity is constant, acceleration is zero. If velocity is not zero, either acceleration is not zero. So if acceleration is greater than zero, our curve, our parabola is going to go up. If acceleration is less than zero, meaning a negative number, then our curve is going to go down. Acceleration being a negative number would mean that we are slowing down, that our velocity is not increasing anymore, our velocity is decreasing, and we are slowing down. So the sign of the acceleration, whether it's positive or negative, tells whether our parabola is going to go up or whether it's going to go down. Then the magnitude of the acceleration tells us how wide our parabola is going to be. The greater the curve of the parabola, the greater the magnitude of the acceleration. So the greater the curve, like this one right here, means it would have a much greater magnitude of acceleration than compared to this one out here, which is much wider. Okay, so the sharper the curve, the greater the magnitude. All right, so now we're looking at position time graphs for constant acceleration. Okay, for constant acceleration, it means you are continually accelerating. Doesn't mean acceleration is zero. It means you have a constant acceleration. You're constantly accelerating, meaning your velocity is constantly changing. So all we did is we just combined the position versus time graphs that we already know and the velocity versus time graphs that we already have used. So position, the final position is equal to its initial position plus its initial velocity times time plus 1/2 at squared. So our y-intercept, our vertical intercept, or our y-intercept is just going to be the initial position of the object. The initial slope of that is going to be the initial velocity, because you know it's a parabola starts off almost like a straight line and then begins to curve upward. So that initial slope is going to be our initial velocity. And then the sharpness of the curve, whether it's wide or steep or narrow, that sharpness is the magnitude of the acceleration that you have here. Okay? So again, our curvature indicates the magnitude of the acceleration. The initial slope down here, if we could draw a line tangent to that, that would be our initial velocity. And then our y-intercept, where it crosses that y-axis, is going to be our initial position. All right, position versus time graphs for constant acceleration. The thing to remember is that you can have both acceleration. So this one parabola, the single parabola, shows that the object is both decelerating and accelerating. So it's accelerating on this side, it reaches the top of its curve, and then on the other side begins to decelerate. Okay, so your velocity is going down, your acceleration is going down, and so we say that it is decelerating. Yeah. So free fall refers to motion determined solely by gravity. Free fall solely by gravity. And this starts the fourth section, and we already have a video for that, so I'm going to stop here.